In this video, I'll explain how JPA deals with foreign keys and relationships between entities. There are lots of differences between object-oriented design used in Java programming and the relational model used in a database. One of the most important differences lies in how they treat relationships. In Java, you relate two objects with each other by setting references. For example, if you're building a social network, you might have messages that you want to relate to senders and recipients. So if you have an object of type message, you would refer to the sender by having a properly named sender that directly references objects of type person. So when you call getSender, you don't get a link, you get the sender object directly. In most relational databases, there are no references. Instead, you use foreign keys. In a foreign key, you store the value of the primary key of another table. Then, if you want to relate the two tables together, you need to execute a query that joins those two tables together and matches the foreign keys to the primary keys. In the relational database for a social network, you'd have a table called message with a column named sender that stores person ID numbers. If you want to get the details of senders, you just need to join the sender foreign key with the person primary key. JPA can be used as a simple front end to a relational database. You could just give your JPA entity a sender field that you could use to store the value of the foreign key. Here's an example of what it might look like in code if you were to access the foreign key. You'll notice that we get the foreign key from the message and then use that to look up the person by the primary key. But obviously, this is rather ugly. It isn't natural, and it isn't how object-oriented design usually works. In object-oriented design, you should be able to access the relationship directly. This code shows what a more object-oriented approach might look like. You notice that we're directly accessing the person from the message, instead of having to go through the step of looking up a foreign key. Fortunately, JPA supports this kind of direct navigation. JPA will automatically perform joins on foreign keys to retrieve the other side of a relationship and create that matching or corresponding entity. Now, to understand relationships in JPA, you'll have to remember the different multiplicities of relationships. Suppose you've got a relationship between two kind of entities. For example, we might have a relationship between a message and its sender. Well, a person can send many messages, but a message has only one sender. So we would say this is a many-to-one relationship. A one-to-many relationship is just a many-to-one relationship in reverse. So we could say that sender is in a many-to-one relationship between a message and a person, and the opposite of this is that there's a one-to-many relationship between the person and a message. We'd say that one person could have sent many messages. Now we know that a message has a sender, but it also has a list of recipients. While a message has only one sender, it could have many recipients. So one message can have many recipients. And conversely, a person can be the recipient of many messages. So we would say that the recipient's relationship between message and person is many-to-many. Many messages can be sent to many people. One-to-one relationships are less common. This is where an entity of one type is related to at most one entity of another type, and vice versa. One example could be if in your social network you've got a paid membership, so you need a table with the payment details of the paying customers. In this case, a person has at most one paying membership, and conversely, a paying membership is always associated with at most one person. Each of these relationships types can be tracked by JPA. They each correspond to annotations on your entities. Let's look at one-to-one first. To define a one-to-one relationship, all you need to do is declare the relationship as a field and then add the one-to-one annotation. JPA will automatically figure out that there needs to be a foreign key in the person table, and that has to match the primary key of the paid membership table. If you want, you only need to declare one side of a one-to-one relationship. However, if you want to be able to access the person from the paid membership, in addition to the paid membership from the person, then you can add an equivalent relationship on the other class. Here, mapped by tells JPA that actually, this field is just a view of the other side. If you are using two sides of a relationship, then the side without the mapped by element is referred to as the owner. So in this case, the person entity is the owner. When you're reading data, this distinction between mapped by and owner is not that important. Both sides of the relationship will correctly refer to each other. However, it is important to know the owner when you're updating. This is because JPA uses the owning side to decide what to do when the database updates. There's nothing stopping you from changing the value of the inverse relationship to be inconsistent with the owning side. But if you do that, JPA will use the owning side as the correct authoritative side when the data changes to the database need to be saved. Now that you've seen a one-to-one relationship, you can probably guess what a many-to-one relationship looks like. Here you can see that a message has only one sender, so the relationship is many-to-one. The inverse relationship is optional, but if present, you use the mapped by element to specify the field or property on the owning side. A person might have sent many messages, and that's what we mean when we say that sender is many-to-one. So you'll notice that we can't just declare messages to be of type message. It needs to be a collection of messages so that it can refer to those many messages. You should also note that the inverse relationship is one-to-many. This makes sense because from the perspective of the person entity, the sent messages relationship is one-to-many. One-to-many and many-to-one are inverses of each other. So this single example shows both cases. If you've got both sides of a many-to-one relationship, the owner must always be the side which declares the many-to-one field. Only the one-to-many annotation has a mapped by element. However, there is a special case with one-to-many. The many-to-one side is optional. You can declare a one-to-many relationship with no inverse. In the database, a one-to-many relationship is created by putting a foreign key in the other table. So in this case, JPA would automatically add a foreign key to the database table for the message class, even if the message class doesn't declare an inverse relationship. Finally, many-to-many relationships just look like what we've already seen. Behind the scenes, JPA implements many-to-many relationships by creating a separate table for the relationship pairs. If you use JPA to automatically generate your database, you'll discover that JPA has created a join table separate from both the message table and the person table. The join table would contain the message IDs and the person IDs in pairs. As with everything else in JPA, you can override these default behaviors. For example, here's how you might override the name of the join table used in a many-to-many relationship. Okay, so those are the types of relationships in JPA. Once you've declared the relationship, then you can just use your entities like you would any other object-oriented code. Before finishing, I'd like to provide a few more quick tips. I've used lists to represent collections in the entities you've seen in this video. JPA allows you to use any of these collection types. Set is probably the best match to the semantics of relational databases. However, I've used list because it is more widespread throughout Java code, and so it's more commonly used in JPA as well. When you persist an entity using the entity manager, what happens to the related entities? Well, by default, nothing. You need to make sure that both entities participating in a relationship have been persisted for the relationship itself to be persisted. You can override this default behavior by configuring a cascade type on the relationship. These are the cascade types, and I encourage you to look up what they mean for yourself. For now, I recommend sticking with the default. This is simple, but it does mean that you need to remember that if you're creating lots of separate objects and trying to persist them all at once, you need to persist every object separately. You can't just persist one and rely on JPA to follow or cascade through all the relationships and automatically persist the rest. Finally, by default, JPA is lazy. What this means is that if you have defined some relationships on an entity, JPA will not actually load them from the database until they're needed. So, if you retrieve a message using JPA, it just keeps a special placeholder as a list of recipients. It isn't until you actually start iterating over those recipients that JPA finally queries a join table to get the associated values. Normally, this is a great thing that speeds up your code. When you retrieve an entity, you don't need JPA to retrieve everything else it's related to. If you don't need a list of recipients, then the database is wasting its time retrieving those recipients for you. However, the downside to lazy loading is that because it doesn't load everything at once, it can cause lots of separate database queries. You can also override this default behavior by setting a fetch type on a relationship. So in this video, I've covered how JPA handles relationships. If you understand the meanings of the multiplicity annotations, one-to-one, one-to-many, many-to-one, and many-to-many, then relationships in JPA should not be too complex. The most important thing to remember is that if you declare both sides of a relationship, then one of them needs to be the owner, and the other one needs a mapped by element on the relationship annotation. Of course, if you've only declared one side of an annotation, then that declared side is by default the owner.